Okay.
Access. You use this to
Yeah.
show this. Just this.
Well, there's more, but you need long division, yeah. Ugh. Because what do you divide?
I think the number is bigger than this.
You need to factorize this.
Factorize this.
Yeah. Can we continue?
Oh, yes.
I only gave you one question to do.
Yeah.
I'll give you one question for homework. Homework question. Just one question. Let's see. Let's see. Let's see. Let's see. Let us say. Let's say. T. T is not so bad. Okay, so what we're going to do is go back to a different chapter, mappings and functions, domain and range. So if you look back at your book, well, it's a different page in mine, so you have to go back to the front and look for, look at the table of contents. So semester two, there it is. Mappings and function, domain and range. What page is that?
102.
102? Your one might be different. Yours might be the same as mine, which is page 10, yeah? Yeah. Okay. So, what we're looking at today, now it gets more complicated in the next lesson, but we'll keep it simple today. Okay. Domain and range. The domain of a function, let's say fx, is the set of all allowed x values. Example, domain of fx equals root x is, so tell me, in this function, square root of x, what values of x could I use and what values could I not use? I could use 1, yeah? Yeah? So what's the common idea? What values can we use?
0 and minus.
I can't choose
Oh,
minus.
negative.
You can't choose negative.
Yeah, we can use negative.
Can't choose negative. So it's from 0 to infinity.
Oh, we can use 0.
We can use 0.
Okay.
Yeah. This is called the domain. Yeah?
Yeah.
Okay. We're happy with that? Well, what do you think the range is? The range of a function fx is all the values of fx in a set. E.g., range of fx equals x squared. So this function can only give you 0 to infinity. That's called the range. These are the answers
shouldn't be negative.
This can never equal. This could never equal minus.
Oh yeah, yeah, yeah. Okay.
Yeah?
Oh, you means fx. Okay.
Yeah? Yeah, yeah. If the range equals all real numbers, which is minus infinity to infinity, we say it is onto, also called surjective.
What's the surjective mean?
It's another word for onto. And the meaning of onto is this, that the range equals the real numbers.
Onto.
Onto. Yeah. So, is this onto? This is not onto. Because the range is too small. Don't worry, we'll do some examples.
Okay.
Okay. So, firstly, let's have a look at some domain examples. So, example A, fx equals minus 9x minus 7. What's the domain? Domain is, what values of x can you use?
That's a real number.
You can use any number here. Okay? Now, let's have a look at B. So, have a look at B. What's the domain there? What's the domain in that one?
It's a real number.
Yeah, all real numbers.
Yeah.
Okay. C, what's the domain?
The real number.
All real numbers, yeah. Okay, next one. D, what's the domain?
Without two
Can
is a
be two.
real number.
It's all real numbers,
Without two.
yeah, except for 2. That's the domain. Okay. E. Now we have to do some thinking. So what should we do first? We should try to factorize it. Ho ho, ho 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 ho. Calculator. I'm lazy. 39 plus the square root of b squared.
I think it's 90. No.
No. 22 and 17.
How can you use the calculator to
I just use the formula. Minus b plus minus. Yeah. What? Somewhere, this formula.
Oh.
Okay, you know this one. Right, so the answer is all real numbers except for 17 and 22. Okay, F. What's the answer here?
All real numbers.
All real numbers. G. What's the answer here? Well, what we should do first is look at x squared minus 11x plus 18, shouldn't we? I'm going to change that into x minus 11 over 2 squared. I just borrow this, please.
I think this minus 2.
No, I want to do it this way. I like this way. Minus 49 over 4. Yeah. Complete the square. Yeah?
Okay.
So, the problem is, because it's a log,
So
You need to make sure then that this is always positive.
Yeah.
Oh, you know what, Ben? You're right. I'm sorry. I should have just factorized it. So that means you need to make sure x squared minus 11x plus 18 is always positive.
X minus 2 minus 9.
Always positive.
So it's 2, oh no, it's x.
Well, it's from minus infinity to 2.
Yeah. Yeah.
And 9 to infinity. Yeah? H. We do the same thing, don't we? You need x squared minus 20x plus 100 to be more than 0. 10? 10 and 10?
Wait a second.
Really?
How to get a G answer?
Which answer?
G.
Because if
It's this one.
Yeah.
Oh.
And this one.
Without two.
Oh, we have to draw the.
Oh, yeah. Is H this?
Yeah.
But this is always true.
Yeah.
It's always true. So that actually means you can use any x in H. Because this is always more than 0.
Yeah.
It means you can use any value. Yeah?
Yeah.
Okay. I think you get the idea. So that's domain.
So how about 10?
How about what?
10.
Tan?
10.
10.
10?
Yeah. 0.
Oh, thank you, Ben. So tired. Anything except 10, because 10 you can't use because that would make it 0. Thank you, Ben. I'm so
I
sleepy.
think we can be 0.
For which one? H?
Yeah.
Yeah, it can be 0.
Six.
Sorry. Because it's like this.
Yes.
It's like this. Okay. Thank you again. You made a mistake. I made a mistake. You fixed my mistake. I made another mistake. You made a mistake. We fixed both mistakes. Right. So that's lots of examples with domain.
Yes.
Now, much, much harder is range. So let's have a look.
Yes.
Okay. So A. You want the range of the function 6x plus 8. Well, this one
Yeah.
is all real numbers because you can think about it like this. On the graph, you get all the values on the y-axis.
Yes.
So it's all real numbers. Okay, that's fine. What about B?
We just draw these.
Draw what? For A?
Like these are.
Yeah, that means all real numbers, yeah.
But can we just?
No.
We have.
Yes. It must have 2 lines.
Okay.
This is called blackboard or is the name of this one.
Oh.
Yeah, it's a special one. Because you have this one,
How about Z?
this.
Oh.
Yeah?
Oh.
I.
Oh.
Yeah? You like them?
No.
Okay, B. What do we do for B? 2B. Oh, and by the way, so this guy we can say is onto.
Oh, just say onto.
Yeah. Okay, what about B? What do we do for B? What should we do?
Quadratic.
Yeah, it's a quadratic. What do you mean?
It's 2. Yeah, x minus 2 1. Oh yeah.
Yeah,
Oh,
I
yes.
just took the 2 out. But what do we do with this?
X minus 1 square.
Good. Minus 2. which is 2x minus 1 squared minus 4.
Oh.
So if you draw this, it means here, here
It's bigger than minus
it's minus 4. It's always bigger than minus 4. So it means the range is only from minus 4 to infinity. Because this is bigger than or equal to minus 4.
Actually, range just figure out the y
Minimum. Yeah, that's one way. But what about in C?
Maybe something, how to say? I don't know.
What about C? Any ideas?
F.
Derivative? No.
No.
No. No, you don't know. The answer is this. Because the shape will be like this. It must include all the real numbers.
Oh.
Because it's cubic.
Oh.
Because of this. It means it must have this shape. It can't be this shape. Okay. D. What about this? What about that? Now it's getting a bit harder. Is it all real numbers?
without 0.
Yeah, that's it.
Yeah.
It's all real numbers without 0. Because this cannot equal 0. So you can't ever get 0. Now, here's a juicy one. E.
Juicy.
Juicy. Delicious. I like it. Now, what I'm going to show you is a special way to do this one in a few, some steps, okay? So, this is a hard one. So I want to teach you a way to solve this, to find the range. So what you do, step 1, you just make fx equal to y. So you get y equals 1 over x squared minus x minus 12. Okay. Step 2, pretend y is constant and express as equals 0. So I'll explain that one now in a minute. So what you do is you try to change this into equal 0, okay? But you pretend that y is a constant, like y is just some number, like 4, whatever, okay? So if y was a number, you would just bring this up here, wouldn't you? Like if this was like a 4, you just bring it up. So you'd get yx squared minus yx plus, was that a 12? No, minus 12. So minus 12y equals 1. Now remember, if y is a constant, then you would bring this over to add it to this. So you'd get yx squared minus yx, and then these would add together, so it's minus 12y minus 1 equals 0. Okay, good? Right? And then the final step, step 3, for what values of y is this solvable? So, the question is, I want this to have an answer. What type of equation is this? What's this one called? This is a quadratic. And I want it to be solvable. I want it to have answers. So what do you remember about quadratics if you want them to have answers?
Delta.
Good, yeah?
Ah,
You go on delta? What about delta?
bigger.
Yeah?
Zero.
Bigger
Be equal.
or equal 0? So you get then minus y squared minus 4 y minus 12 y minus 1. That needs to be bigger than or equal to 0.
Yeah.
If you solve this, you get the range.
Oh.
Yeah, so let's solve it. So that's y squared minus minus is plus 48y squared. Yeah? Is that right? And then minus plus 4y greater than or equal to 0. So that's 49y squared plus 4y greater than or equal to 0. So that's y, 49y plus 4 greater than or equal to 0. So if you draw that, that's here at 0 and minus 4 over 49. Okay?
And
So-
is
And it's this shape,
this
because it's more than. It's this shape, because it's y squared. And you want this piece and this piece. So you might say that the range is minus infinity to minus 4 over 49, and then 0 to infinity. Wait, we have to check something. Go back here. Don't forget, for this to be a quadratic, you also need y to not be 0.
Oh.
Now, is y 0? No, so we're okay. That's okay. Oh, sorry. It's equal. So this one here is closed because it's equal. But this one I keep open because I don't want 0 here.
So just
So I should really say here, Ben, if you prefer, for what values of y is this solvable if this and y can't be 0? Because that's like the A.
so we just cancel the 0.
Yeah, you can't have that one.
Okay.
Yeah. It's hard.
Oh, we just discussed.
Oh, disgusting. You think so? Well, the good news is my answer's right. So.
Oh, it's fine.
Now, I want to draw this for you when you're ready.
No. But nearly.
You wrote it down?
Okay.
Yeah? Now, what I want to do is just go back to the last example. Where's it gone? Where's it gone? This one here. Let's do this example. So let's say I had 1 over 12x plus 12. Let's use my same method, okay? Step 1, you make y equal to this. Step 2, you get 12yx plus 12y equals 1. Step 3, you make it equal to 0. Oh, sorry, that's still step 2. You make it equal to 0. So that's 12yx plus 12y minus 1 equals 0. So that's like 12yx plus 12y minus 1 equals 0. What type of equation is this? Oh, you need to go to Emer. That's right, yeah.
See you.
See you. What type of equation is this called?
What time?
Yeah. Is it quadratic?
No,
No, what is it?
linear.
Linear. So step 3, you want to solve this. So what does that mean about y? Well, look, if you had mx plus c equals 0 and you want an answer, when do you not have an answer? When is there a problem? When can't you solve this? You need the m to not be 0. Because if m was 0, you can't solve this.
But
Yeah.
I can get a linear. Just
Yeah, but it will never it'll never equal 0.
oh yeah.
Yeah? So that means 12y can't equal 0. So that means y can't equal 0. So the answer is all real numbers except 0. Which is what we said earlier. Same answer. I think you should write this example down. It's an easy example. Easier example.
Yeah. The can be equals is this side or this side?
This side.
This side.
Yeah.
This side. Okay.
This side.
I always write the opposite.
What?
It's
Like this?
yes.
That's outrageous. You write like this?
Yeah.
Oh, you're so strange, Dan.
Yes.
Now, let's do, I want you to know that the domain of sine inverse x, what values of x can you use here?
Bigger than 0
Yeah?
and smaller than 1.
Nearly. -1 to 1.
Minus 1.
So, I'll give you this question.
Oh, of course.
Yeah. So, I want you to try this one for me. Oh, hang on. I'll give you a minute. What is the domain of sine inverse 2x plus 3? Let's try that for a minute.
Just don't it. So it's
Try it right there.
is
Yeah.
how to say is equals m bigger or bigger than -2 and small or equals -1.
I don't know. I don't think so.
Okay.
Let's have a look. So, because it's sine inverse, we need 2x plus 3. It must be in this set.
Yeah.
So that means 2x plus 3 must be between -1 and 1. Oh, I'm sorry, Ben, maybe you're right. So that means minus 4 is between 2x and that's less than minus 2. Minus 2.
Minus 1.
Yeah, minus 2 to minus 1. That's what you said.
Just the same.
Yes, beautiful, beautiful, beautiful. Okay. I think we get the idea. We've done lots of examples, so let you try some. Let's see. So from question 1, I want you to do I, J, K,
Wait.
L, and don't worry, write it down. O, P, Q, R. Yeah. I to R. And 2, the same. And then 3, 4, 5, and 6.
That's it.
Well, they're kind of short.
Yeah.
They're not like last time.
But maybe difficult. More
Yeah.
difficult.
Huh?
Maybe more difficult.
What's more difficult?
Short one.
No.
No.
Now, the only one that's difficult is like K.
Oh. Disgusting.
Ah, yeah, it is. Give it a try. Oh, wait, no, before you start, I wanted to show you something. Wait, Ben.
Oh, I just. Okay.
1 second. I wanted to go back to question E, where you had this one. 2E. 1 over x squared minus x minus 12. Now, what did we say the answer was?
Wait.
It was something like, yeah, this one here. Yeah, this. Now, watch. I make a graph, okay? Now, hang on. Hold on. Whoa. So you see, you get all the real numbers up to this number, then you can never get these values, and then you continue again from 0, but you can't have 0, because it never reaches 0. So you have this piece missing here. You can have this, but you can't have this.
Yeah.
So if I zoom in, where is it? Zoom in onto.
So range just cover the y.
Yeah, it just covers the Y. Oh, where's my center on cross? Plot, trace, center on cross. There you go. So, what did we say? Minus 49, was it?
4 over 49.
4 over 49? Let's see.
Minus.
Oh, but we know. Because I just want to get the number here. 0.08. Yeah. See, so it's right. Okay. So that's another way to do it. Is to picture the graph. But this graph is difficult. Right? Okay, sorry. Now you can try the questions.
I think the domain.
Yeah.
Domain.
Yeah.
Is
Domain.
easier.
Ah, it's very easy. It's very easy.